let y of x be the function that solves the differential equation x dy dx plus the quantity of 2x plus 1 times y equal x times e to the negative 2x, with the condition that y of 1 is 17 over 4e, and we're asked to find the function y of x. The first step is that we need this in standard form. When you have a linear ordinary differential equation, the standard form is dy dx plus some function of x times y is equal to some other function of x. So for us, this x here needs to be moved. We need to divide by it every single term. So we cancel out these x's. We cancel out these x's. And with the middle term here, the second term on the right hand side, it's very important that we can represent it as a function of x times y with the plus sign. And so we can take these two terms in our numerator, divide them by the one term in the denominator, and end up with 2 plus 1 over x. Alright, great. Step 1 then will be to find the integrating factor. It's very important that we write the standard form equation in this manner so we can highlight exactly what p of x is, because the process of finding the integrating factor starts with integrating p of x. In this case, 2 plus 1 over x. Integrate that, the antiderivative is going to be 2x plus the natural log of x. The integrating factor uses the Greek letter mu, and it is e to the integral of p of x dx. So it'll be e to the 2x plus the natural log of x. And next we'll employ a property of e, or any exponential, e to the a plus b is e to the a times e to the b. So we'll have e to the 2x times e to the log x, because these guys can cancel. And it comes down as just an x. So your integrating factor is x e to the 2x. On the next slide, we see what to do with that. Why is it so important to find this integrating factor? And so we have our summary of where we're at this point. The differential equation in standard form, the initial condition, and the integrating factor. So let's multiply the standard form of the equation by that integrating factor, x e to the 2x. And so the only thing that really we can do as far as simplifying this is on the right hand side, this e to the negative 2x times e to the 2x cancel out and become just an x. The purpose of the integrating factor is, after multiplying through by it, you'll have this special left-hand side. This left-hand side is the derivative of your integrating factor times y. So the next step in the process is just to acknowledge that. Rewrite the left-hand side as d dx on mu times y. What's your mu? Your mu is x e to the 2x. Do nothing to the right hand side, leave it as an x. And it's desirable to have the left hand side in this form, because the very next step in the process is to integrate both sides. Let's do that on the next slide. We're going to integrate both sides. We integrate the left, we integrate the right. So we put our symbols in, and we use the fundamental theorem of calculus, which allows us to cancel out these operations and leave us on the left hand side with the integrand. Right hand side, the integral of x. Don't forget though that you need to remember the plus c when you write the x squared over 2 plus the c. Okay, great. As soon as C comes in, my recommendation is to get rid of it. So the sixth step in the process is to plug in the condition to get that C. When x is a half, y is this strange value 17 over 4e. You'll see why that's chosen once it all works out. So every place you see an x, put a half. Every place you see a y, put a 17 over 4e. Okay. Well, 2 times a half is 1, so that's half of e times 17 over 4e. Okay, great. What about the right-hand side? Well, you square a half and you get a fourth. If you cut a fourth in half, you get an eighth. And so our e's will cancel on the left-hand side, and then we'll have 17 over 8. Take away 1/8, and we have conveniently 16 over 8 is what C is, more commonly known as 2. So go back to our current state of the problem and replace the x by 2. I'm sorry, replace the C by 2. And then we go to the last step in the process, which is for us to answer the question that's being asked, and that is to basically to find the function y. Y is being multiplied by x e to the 2x. We'll divide by it. Leaves us just with y on the left-hand side. On the right-hand side, well, the x squared in the numerator of the numerator and this x in the denominator can cancel. But pretty much there's nothing else you can do to simplify. We'll call this x over 2 e to the 2x, and then this 2 over x e to the 2x. And we'll leave it like that. That's our function that solves that original differential equation with that condition.